One. Hello, class. Welcome to the Cloud Solutions and API Integrations class. This is class 5 in the series. API Integration for Data Science. I am Jeremy Bergman, instructor for Omaha Data Science Academy. And tonight is where we are going to take all of the different parts of what we have learned so far in class, as far as storage, how to use REST APIs, data processing in the cloud, and we're going to use those three pieces to integrate a crypto pricing pipeline within Microsoft Fabric. And on top of that, we'll also learn focus on the data engineering piece of Fabric, which contains what Microsoft calls Synapse Analytics. So it really includes like a data warehouse. It includes Spark notebooks, SQL notebooks for large workloads and like real-time streaming data. It includes Cosmos DB, which is like your NoSQL and those other things. And then it includes its own pipelines specifically made for analytics. So we'll have another tool in the toolbox in this lecture once we are finished. And then could be able to create an end-to-end data pipeline to visualize in PowerBI. All right. So how is this class structured? Give me one tab into the right tab. In hour 1, we will dive deeper into Microsoft or Fabric data engineering, which I just explained is also known for Microsoft as Synapse Analytics. It's meant to be an analytical platform to make the processing of data and sharing and collaboration on data science projects easier. And it's also highly integrated with other Microsoft products. Hour 2 is automating data collection using REST APIs, data pipelines, and Python notebooks. We'll focus on that and practical example in the second hour. And then the third hour, we'll go hands-on creating a data factory pipeline connecting the live CoinWatch API and data warehouse, which is directly relevant to what you'll be doing for the class project. And then at the end of hour 3, we'll probably go offline after this, and then I'll record a video introducing the class project separately. Okay. So class 5 objectives. We'll overview the Synapse data engineering. It's an integrated platform, and it has a bunch of components for big data, data warehousing, and data science. I almost think of this as like the data analyst and the data science part of this entire platform, where the data engineering is like your data factory, your data warehousing, your real-time analytics, and working with data. It is a data engineering IDE. It also includes its own data factory type pipelines and allows you to build machine learning models, has libraries for that in Spark, which Spark is like a big data processing platform that allows you to parallel process data. But it also contains these machine learning libraries where you can create those type of models also. So in the first hour and headed into the second hour, we'll look at SQL and Spark pools, how you can create the on-demand SQL pools in Synapse Analytics and Spark pools in Synapse Analytics. So they're like little servers that you can spin up on demand for data processing. Our first example will be one lake query using SQL serverless pool. Then the second will be PySpark data frame example. So there is a version of Python notebooks within Synapse Analytics. It's specific to Spark. It has libraries for the Spark server and data processing. And it has data frames, so a lot like if you're familiar with Python and Pandas, a similar idea, but built specifically for Spark and parallel processing. So the last part will be automating data collection using APIs. So we'll go into importance, benefits, and a real-life application with the crypto data, and then we'll use data pipeline to be able to automate the process. So what is Synapse Analytics? We briefly introduced this in the data processing last lecture in data processing. This is where we will dive deeper into Synapse Analytics. So it's all-in-one platform for analytics projects. It's integrated development environment. If you're familiar with that, that's like using the MySQL example. MySQL Workbench is an integrated development environment. It allows you to write code and execute code, save, manage SQL code in projects and databases. If you're writing Python code, maybe you use Visual Studio or something, and that's the same. You write code within it. You have an interpreter. You can execute code to see how it works, and then you have a lot of things around it to manage your code. So Synapse Analytics is similar from data science perspective. This is like Microsoft's attempt at putting together like that all-inclusive, collaborative, integrated development platform and environment for data scientists and data engineers. So Data Lake, it includes that. It includes integration with either Azure Gen 2 storage. You'll hear that. That's a version of OneLake that's in Azure. For Fabric, it'd be OneLake, but it has integrations for both of those. Data warehousing, it has on-demand data warehousing. So you can create relational model structure for analytical purposes. It includes Azure Purview. We won't really get into Azure Purview this class, but Azure Purview is like a data management and data dictionary and data stewardship tool to be able to document your data sources across the organization. So since we're just focused on building a pipeline, we won't go into that too much, but just the awareness that it's out there and it's part of Synapse Analytics. For analytical processing, you have on-demand SQL Server, so specifically Microsoft SQL Server and on-demand pool, and Apache Spark for analytical processing. So when we say on-demand, so it's not a server that's always on like you typically think of things. It's only when you need to be able to do analytical processing. That way it saves quite a bit of money. And these tend to be in Synapse Analytics, really high performing, like high-end databases. So it'd be really expensive to run it all the time. So you just you'll see where you can just spin these up and do your calculation and then shut them down after you're done processing with them. So it's kind of like a light switch, turning and being able to turn it on and off for processing. Data analytics includes PowerBI and Synapse machine learning. We'll learn about the machine learning module in the next lecture. And also it includes Apache Spark libraries for doing machine learning. Data processing, it has its own version of Azure Data Factory. It has Data Explorer for real-time data sets and data flows. So data flows like we did in the last class. And it's built for collaboration, as I mentioned, data scientists, engineers, analytics, and consumers of data. Okay. So data engineering, the Synapse Analytic features. So this is going to say Azure Synapse Analytics, but data engineering also has all these features. So integrated analytics, big data and data warehousing included in a single service. It includes visualization with Power BI and analysis with Data Explorer. We don't really cover Data Explorer in this class, but Data Explorer is specifically for being able to query and summarize large data sets. It's a tool for that, like streaming data sets or large data sets. I'll cover it as part of the real-time intelligence lecture next week. But won't need it for the class project. So as data integration with Azure Data Factory, you can build pipelines and mapping data flows. Like we saw in Azure Data Factory, the last class. Synapse Analytics has its own version of that specifically for analytical processing. So on-demand query processing, I mentioned the on-demand tools, Data Warehouse and Apache Spark. Both have serverless pools. Apache Spark integration allows you to perform big data analytics, facilitating seamless combination of tasks. There is seamless combination of data integration, ETL, Python, and machine learning tasks. In addition to Python, you can also use R, the R programming language. So that's like a statistical platform and library to create models. You can use Scala, which is more like a big data processing language and language. And then SQL you can use within it. You can use Spark SQL to query across data sets. You have management tools, so unified environment, you can manage all the processes with monitoring and managing and security. And then developer tools, SQL, Python, Scala. And you can get to it for version control also. So contains ingest, storage, compute, and visualize, all the things that we talked about so far in this class, all in one platform, including on-demand pools. Okay. Synapse Studio IDE. So it doesn't quite look like this in Fabric, but it's nice to know the Azure version and the different things that you can do in it because it's the same, just a different interface within Fabric. So Synapse is a unified web-based interface for it in Azure. It serves as a central hub where users can manage and monitor all aspects of a data solution. In here in Synapse Studio, just like in Microsoft Fabric, you can create and run SQL scripts, can integrate and analyze data using notebooks. We'll see examples of that. You can use Spark notebooks. Build, manage, and monitor jobs. So you have pipelines, SQL and Spark pools, data flows. You can design data pipelines like you would, and data flows like you would. In Fabric, and built-in exploration tools, Power BI and Data Explorer. So really, Azure has taken this Synapse Studio and Synapse and made it even simpler in Fabric. You don't have to do as much configuration of data sets and everything. It's all in one inclusive, very easy to configure and use module, which is almost all of it is in the data engineering module in Fabric. Okay. So forgot to paste. No, I didn't forget to paste the picture there. It was hiding from me. All right. So Synapse SQL pools. I'm just going to focus on this. Synapse SQL is a core component that allows you to run SQL queries across your data. Includes two distinct functionalities. So you can do on-demand queries like we talked about. You can query directly into the data lakes or OneLake in various formats like CSV, Parquet, or JSON. So throughout this class, we have worked on trying to query in Parquet, the Parquet file inside of OneLake. This one with these on-demand queries will show you a concrete example of doing that. And dedicated SQL pools. So you can create a dedicated SQL pool or a server if you need it to be up all the time. This is often useful for data warehouses that you need analysts to be able to access constantly or be able to refresh data. It's more cost effective to have, well, it would be more cost effective to have a dedicated SQL pool than run on-demand queries all the time. Although on-demand queries could be very useful for things like real-time data or just being able to get new data sources. So it's a balance between the two. If you need something that's always on and cheaper versus serverless and can be spun up and used quickly whenever you need it, is a choice the engineer often makes. The dedicated resource is scalable and allows for complex analytical workloads with predictable performance. So that's one way of thinking about it too, is if you just need like a dedicated predictable resource, a dedicated SQL pool would be good for you to use, which would be like your typical SQL, cloud SQL databases, MySQL or Microsoft SQL Server. Has both of them. Okay. So we are already to an example. We're flying through this lecture today. So we are going to query a using serverless SQL. We are going to query a Parquet file that's in the data lake. I have an example here of a CSV. You can also do a CSV. And it's the same thing, the same idea. You'll use this open row set and then your full path to your full URL to one lake in the file. You say format Parquet and then the parser version, and then you could select out of that and get your results. So let's go ahead and give this a try. I am going to go ahead. Oops, was I sharing that the entire time? Everybody was able to see those slides?
Yep.
I did, okay. I minimized it and it went away and I was like, oh my gosh, did I just talk through all of that? And it wasn't even up there. I thought it was. I checked before I was talking. But my present thing wasn't, also went away too. Let's see. Okay. I would have just began to cry if that would have happened. Okay. Let me go ahead and open up here what I need. Just 1 second. Go ahead and share this screen. I have the example already up here. I'm going to share the entire screen. Bear with me while it goes crazy for a second. Okay. Oops. So actually I need to pull this down. Okay. Can everybody see this Lakehouse ODSA test, ODSA workspace, along with the SQL query editor?
Yep.
Yes.
Okay, excellent. So what I actually want to do here is go into data engineering. And you see inside of that, I have my data engineering workspace that we created a while ago. And I'll also notice we have a bunch of these options up here. If you ever forget what item you need, there's actually some different options here. So there's one data analytics using a SQL Analytics endpoint, and then it'll give you like the different things that you need to be able to do it, which is kind of nifty. I just wanted to point that out because that can guide you if you get lost. So go inside of this workspace. And we'll go to, hold on one second. I actually want to, I'm not sure where it went to. In here, we do want to go back into that workspace, create a new item. If we go click on all items, you can see everything here. So you can see get data. What we want to do is the warehouse in this one. So we set that up. Call this warehouse first and last name ODSA. So I could actually do demo user ODSA test. That's what I've been calling all these. You can put it under your name, first and last name. So it takes just a second to be able to load that, but now you have a new warehouse. This is your on-demand pool. And you can see it's really similar to a regular SQL Server warehouse, is that you can create your schemas in here. We don't have to do it now, but you can right click and we'll give you the code to do that. And you can save all of your queries. So when I did that, you notice that it's SQL query. A SQL query came up to create a schema. You could give that schema whatever name you want. Later on, we will do crypto data warehouse, DW. But for now, what we'll do is create a new SQL query. Okay. So from this slide, I'll copy and paste. I can't really copy and paste it. So the first thing we need to do is get the location of the Parquet file or CSV file that we're looking at. So I hope I saved the Parquet file here in this data lake from the last, say in our last class, when we did the data flows and then we picked a location, that's where it saves a Parquet file to the data lake. So let's go ahead and see if we have that in here. So to do that, open a new data engineering tab. Actually, yeah, I kind of want to open a new tab because I want to go back to that one. Okay, let's go back to data engineering. So what we want to do is get that full URL for this full URL and path for the file. So we can do that by going back to the data lake. So inside of our workspace is where we already have the data lake set up. So go to our lake house. And we have files in here. We did save one file that is a Parquet file. I don't think that'll actually let us preview it like that, but be able to hit properties when we get to that file. And then we have this full URL. So if we copy that to the clipboard, that is what we can use in our SQL query. So it has the full URL for our data lakehouse. You can see this one is a workspace. This one is our lakehouse item. And then it finds the file inside of the lakehouse. That's how the URL reads. So we can select star. And so in the from is where we're going to do this open record set to be able to load files in on the on-demand SQL pool into a table-like structure. As in the from statements, if you remember, those are the tables or maybe sometimes subqueries that you're bringing in. You could almost think about this as a subquery that creates a tabular table that you can select from. So I always forget this. Syntax, open row set. And then you notice, like we do in MySQL, this is Microsoft SQL Server, which is really similar. We'll say as a, we'll give that subquery an alias. And then we say bulk. So what bulk is doing is bulk loading that file, which is a feature of Microsoft SQL Server that you can use to be able to import data from like some type of flat file or other type of data source. So then once we have that, we need to specify the format. Put a comma there. And then you could just say format Parquet. Format is equal to Parquet. Well, let me see if that's right. I feel like that should light up in blue. Yeah, it should. Format is equal to Parquet. Where am I going wrong here? Yeah, we'll just try it here at the end. What am I forgetting here? Format Parquet, we'll give that a try. So, looks like I have some type of syntax error here because of that being underlined. What am I missing here? From open row set. From open row set, bulk, format CSV. Oh, it says, oh, here open row set is not supported. Okay. Interesting. Okay. Let's go back to data warehouse. Let's try to do this query from here. So we will go back here. House. So were we just in our warehouse? Let's give this another try. Oh, it says it's not supported within the warehouse. Okay. So go back to the data lake house. Give this a try in here in the SQL endpoint. Okay. So I went to the SQL endpoint. We're going to try this. We are going to try this here. If it doesn't work here, we'll go to break and we'll figure out what's going on. So instead of the warehouse, he'll go here into your SQL endpoint. You can find that. If you go to data engineering, and then you go to your workspace, and then you go into your SQL Analytics endpoint, and you click on that, that will give you this SQL editor. So what I did was created a new SQL query. So I have open row set here. This looks like it's going to work here. So let's give this a try. Open row set is not supported. Okay. I'll give everyone a quick break, 10-minute break. And I'll go ahead and figure out where I'm going wrong here, why open row set is not supported. And then when we come back, I'll show everyone here how that works. And then we'll get into Apache Spark notebooks. And then we'll do data frame. And then we'll recap the class and put together our pipeline using API data. So go ahead and take a 10-minute break. I'll research this real quick. Should have a solution for you. And be right back. 10 minutes. I just took it for granted that that was going to work in the on-demand data warehouse. It does in Synapse Analytics. Just doing a search for it right now. Okay. So it actually looks like here that feature is turned off in the on-demand pools, but it's available on the full-time server, which is the dedicated SQL server. So I'm gonna give that one a try real quick. Going to spin up a dedicated SQL server. New item. Okay, manage SQL server, going to set that up. I think I figured it out. Just have to set something up.
Is that a library issue?
No, it's not supported for whatever reason in Fabric. They took support out for it for the on-demand. And it didn't, of course it didn't. Took it for granted that it was going to work. ChatGPT's broken. It's unavailable.
Yeah, I tried to use it earlier and I couldn't.
Yikes. Okay, have a backup. I have Claude.
Claude was mad at me earlier too, so I don't know if there's some sort of cyber attack going on against the AI, but
Yeah, maybe.
Oh, a new iOS came online. And so there's a lot of iPhone connections with basically denial service.
That is engineering.
No,
It's like what happened, I know, like-
it's adding something to a phone without checking whether the actual service can handle that type of load.
That happened to CrowdStrike, if anybody, a few months ago. If anyone heard about that, that's like the antivirus detection software. They have cool technology to like detect new attacks using machine learning and AI. But they did an update and it just wrecked the operating system of like millions of computers. Like they deployed it and wrecked it.
What I heard is they deployed it and it was fine. Windows didn't update and then everything went down. So something with that update broke what they had.
So yeah, they probably, yeah,
It's still technically their fault.
I might
Oh,
say
it's
it.
only Trump's.
yep. So I found out Fabric, the open row set's only available in a dedicated SQL instance. So I'm looking to set up a dedicated SQL instance real quick. They took it out of the on-demand pool for in Fabric. It works in Synapse Analytics, which is why I'm surprised that why I was caught by surprise that that wasn't working. Let's see, to set up a dedicated SQL instance in Fabric. Okay. Dedicated SQL endpoint. Claude didn't give me very good directions. You know, Claude's not that great outside of generating code. It's amazing at that. And then solving like problems, like step-by-step problems. It kind of sucks at everything else. We're creating like process documents. It's great at that, like process-oriented tasks. Yeah, okay. One more try. Like we're taking a look at a dedicated instance earlier in the class. Just a couple more minutes here. You can create a new SQL database directly within the Fabric workspace. Navigating to the database workload, the Fabric portal. Okay. I thought so. I'll share what I'm doing here, so I'm not just sounding like I'm talking crazy. Okay. So the open row set that I was trying to do queries into the data lakehouse, it's disabled in both the on-demand SQL Server and your SQL endpoint that's in Microsoft Fabric, your SQL endpoint for the OneLake. In Azure, it's not. You can do that in the on-demand pool, but it looks like it's still available if you do a dedicated SQL instance within Microsoft Fabric. So I'm going to try to set up a dedicated instance real quick. So if we go to portal, oops, not Azure. I'm so used to typing in the Azure portal, fabric.microsoft.com. And I thought that there is a databases option around here that we explored earlier in the class. Let's see if we can just find it. Data warehousing is your on-demand SQL Server pool. So it's not going to work there like I tried there at first. If we go create, factory, let's scroll down here, data science, data warehouse. This one does a replicate. This replicates an existing Microsoft SQL Server database. So this is, I was looking at that during break. That isn't exactly what we need. Warehouse. Create that item from in here. Oops. When you create an item, it gives you the same items across all of these. So I don't think going into create a T-SQL notebook. Let's try to create a T-SQL notebook real quick. Otherwise, the way to do it is probably through a pipeline into your on-demand SQL database or a table inside of OneLake. Okay, so we have T-SQL. Oh, let's try to do this open row set from the T-SQL workbook. Probably not going to work. So I did that. Hit run all. Data warehouse ID is empty. So let's go ahead and choose our warehouse. Have to do that first in the T-SQL workbook. Let's try to do this again then. Okay. No, it's not supported there. Okay, if I find that out for everybody, I will put that in Slack for everyone. That is something I want to figure out, and I can't seem to find where I can set up a managed SQL server today inside of Fabric. So I'll get back to everyone on that and how that works. But T-SQL, what you can do or the SQL server endpoint that I was in. You can even connect to your lakehouse. You could query existing tables that you loaded in the lakehouse like we did in the first couple lectures. Or if you set up your own data warehouse, your on-demand SQL warehouse. So this is the lakehouse right now. You also have your warehouse that you can set up. And inside of here is where we'll do the crypto data. We'll see shortly where you can set up create a new schema for crypto data, and the example will load data into those tables. Okay. So I'll figure out about open row set, and maybe they may have disabled it because they want you to do these by pipelines instead of open row set. I'm not sure why they decided to disable open row set and query files directly in the data lake. I would think that would be useful, but now you can load them into tables now where you can do you can use Data Factory to take that file, connect to that file, and load it into a data warehouse table like we did with those CSV files. But to query it directly, they seem to have taken away that feature. Okay, but available in Azure in a similar tool. Okay, so we'll keep moving along in this lecture so we get plenty of time to work. Okay, I will go to presentation. Can everyone, we're back to the lecture. Can everyone see the lecture on StreamYard?
Yeah.
Yep.
Thank you. Thanks for confirmation. Okay. So Apache Spark, say here, Apache Spark is another on-demand pool specifically for big data sets, like real-time or just like massive transactional or log type data sets that are difficult to process in a traditional relational database environment. Be surprised a traditional relational data set or a relational database, it can really handle quite a bit. But when you're talking batch loads of millions upon millions of records, it can run into some challenges. So Spark is made specifically for that purpose, and then to be able to do machine learning on a large scale. Okay. So in the managed Spark environment, so Apache Spark provides a managed Spark environment. You can provision, scale, and do maintenance of Spark clusters. Spark cluster is what you spin up to like a server that you use to process. I'd lost that word earlier. It's compute clusters. So clusters of like little CPUs and processors and computers that you can spread out all of the processing to of the big data set. Language support supports Python, Scala, Spark, SQL. It also supports the R programming language. Built-in collaboration. So the purpose of, I don't know if you do this in your Python class, you use Jupyter notebooks, or you do in the machine learning class maybe. It's really to be able to do those step-by-step processes or analysis, particularly made for like the different steps that you need in a machine learning model, like from maybe some data prep to data exploration and then building the model and checking the model results, model evaluation. And then it's really for like collaboration. So a data scientist would build that notebook and then be able to share it with the data engineer or other data scientists, and then implement it. Well, performance optimization, highly optimized for big data sets and scales to big data sets, automatically adjusts the amount of computational resources based on the workload. So beforehand, it'll actually look at your workload and then try to determine how big it is and what kind of resources it needs, which is kind of neat, and then allocate accordingly. So it tries to do that optimally itself. I believe inside of Spark, you can specify your resources that you need, but it tries to do it, tries to compute it itself and be as efficient as possible. So it has direct data access. Spark pools can directly access data in either Azure Data Lake or OneLake and other storage services. So we could probably try to use SQL and Apache Spark to do something similar like Rosette that we're trying to do out of the SQL on-demand pool. We could give that a try during our working session. And then ML tool integration. So it includes these machine learning libraries. Oftentimes machine learning libraries, so machine learning models in general, they just need a lot of data, one, to be able to build it, and then two, to continually update the model. Oftentimes these are oftentimes they're small enough where you could do it within a relational database, but sometimes they're big enough, like image recognition or large language models or so forth. That takes this massive computing power just to be able to create them. That's why they talk about like OpenAI, like having a big advantage because they work with Microsoft and they have access to like computing resources that nobody else does to be able to build these models. While that'd be at that scale probably prohibitively expensive for whatever organization you're working with, this actually does give you some resources at like a reasonable cost to be able to do that. If you need to be able to scale up and down to some type of real-time machine learning model would be a model that could use Apache Spark, this type of tool, and then be able to scale up and down as needed. So as I was telling Melinda, if your organization wants to do something real time, now you know about this tool and you can explain the cost of how much it's going to cost to them. It's not exactly free, but in a way, this makes it more efficient and cost effective than it would be otherwise. Okay. So a PySpark data frame. So you see in a very similar way as pandas, or like we were doing with the open row set, you are able to read a file that's in a data lake directly into a data frame. And I don't believe that they would have taken away this feature in PySpark. But let's go ahead. I have more than one example here. I actually have two examples of PySpark. Well, I have one example, and then we'll do that one as a second example. So I'm going to do my first example first, just to show you how you might be able to utilize PySpark. So the first thing I do, I need to flip to the right tab here. But I created a query in Python query in a Spark notebook to go out to the live CoinWatch API and be able to get data. So how you can do that, if you're in data engineering, you can click on a new item. You can do a notebook. So it says explore data and build machine learning models using Apache Spark. I have already done that, created one. So if you do that and you give it a name, you'll notice here at the top, you have a bunch of different options. You have a run all. The language that you want is PySpark, Python, and you see you can have a couple of different options, or you can do regular Python, or at that last try we took an open row set. We were actually doing T-SQL analytics. The environments, I just leave that standard. And you can add these, you can actually add these notebooks to pipelines, Azure Data Factory pipelines once you've completed it. So once you have a process that you like, it can be one of your steps in a data pipeline. So we're just gonna run this one piece at a time. So if this looks familiar at all, it's in Python, and we are going to get the overview history from API Live CoinWatch. So this is like a total market cap history. And I already see one thing in here I don't need. So we're going to define the body. That's this payload. We're going to define the headers with our API key, and we'll tell it what content type we want. We'll use the request library in Python to do a post request to that URL and then it'll print the response. Let's go ahead and run that. One thing you can do while this runs, actually, I thought that you could expand that so you can see that it's running right now. Oh, it says missing start date. Okay. Overview. I think maybe I just want the overview endpoint. Let's go ahead and run this again. There we go. If I went back to just the overview, it's like the current market cap, volume, the liquidity, and Bitcoin dominance as of the moment that you queried it, the most recent moment that the API Live Coin Watch has. Okay. We have like a little JSON file. It's a single record, but it is a JSON file. Okay. So one thing that we can do is once we have a JSON response, we can parse the JSON file using the JSON library in Python with a function called dumps. So it doesn't look too much different, but it is now in a format that we hope will work here with Spark. So now we're using the Spark library to invoke the Spark cluster, and we use this function Spark read JSON. The JSON response that we created, that we put in a JSON type format, and we're saying it's true that it's on multi-lines if you had multiple records. It doesn't matter too much here. We'll go ahead and run this. Of course, I got an error. Relative path and absolute URI. Oh, it's trying to read that. So let's try to do something else. Let's take this original response that we printed out and let's just send that right there. So this wasn't working for me earlier either. Response.text. Can do that as a list. Nope. Can I change the variable name here also to JSON response? Sometimes the variable names can get confused with the libraries. So if I'm just going to go from the top to run it all, this is just going to go through the Spark processor again and see it executed. First cell did, second cell did. Oh, let's call this JSON1. I already called the one below it JSON response. Okay, a JSON response is at JSON dumps. Okay,
You missed one right above that, I think.
Okay.
I could be wrong. Oh, I guess you're skipping over to JSON1. Sorry, the
Yeah,
the JSON response.
It doesn't seem like it likes that format right there for the JSON. So JSON1. Argument path should be a list. So I think maybe it's looking for a path here, and that's the problem that I'm having with it. I did see something like that on some of the message forums. Let's see. So what you could do is save this JSON file to the data lake and then read it as a file. You could go ahead and try to do that. We'll go ahead and ask Claude. Code that writes a JSON file to one using Spark. So usually I'm pretty straightforward with Claude when I'm doing something like this. Loads it using the Spark function.
Spark.read, right?
Spark.read. Yeah. Spark.json.read. Read.json. This is a good use case for an artifact. Hope you can use the write functionality, the open file stream, right? Okay, read JSON from one lake. Yeah, it looks fairly involved there. It's Python native's JSON module to write the file. Spark's built-in JSON. Oh, it has two examples. Okay. Two methods. Schema. Read JSON. Oh, you specify a schema, and then you read it from one lake. Is there any other way to just read this from a variable? Let's go ahead and say create data frame from JSON variable. Must just be missing something. Okay, our JSON data kind of looks like that. Spark create data frame JSON data. Let's try that instead. Notebook. Let's refresh that notebook. So once you get all of this into the purpose of getting it into Spark data frame is then there's all sorts of Spark functionality that you can use when it's in a data frame. You can break it down and parallel process it. You can run machine learning models on it. That's your ultimate goal. So you can see you can use Python in parts of it also, which is very handy. Ultimately, you want to get this in a Spark data frame, and then you could even write this to a database table if you wanted. So you could really create your pipeline using Spark also. So let's try to use Spark create data frame JSON 1 instead. See what happens. Another error. Okay. Has pandas. What's this error say? I can't make. Cannot infer schema for type bytes. Okay. So it doesn't know what type of file it is. It just thinks it's a bunch of bits instead of like a string. Let's try JSON response here.
You may need to, on that one for the JSON dumps where it says response.txt, you may need to slap your JSON 1 in there instead, I think, right?
What was that? Oh,
On
JSON.
Yeah, I think right there we need to slap in the JSON 1, right? Because
Because I changed it from response. Thank you. Okay. Let's run that one first.
We may need to still have .text on there, possibly.
Maybe I need to run it from the top. And then JSON response. Let's run this from the top. Cannot infer schema for type string. This is where Stack Overflow is perfect. Boom, Stack Overflow is on top. Okay, similar idea. Uses Lambda SQL types. Let's try to see what Claude does here. Not quite the one that I'm looking for. Sometimes Claude will update the code when you get an error. Let's see. He knows that Claude knows the error. This is what really saves me a lot of time using AI. This is a good example of it. Let's see. Parse JSON string into Python dictionary first. That looks like what we're doing. We just need to turn it into a dictionary or a list type here. Or use spark.read.json like we did before. Okay. So this turns it into like a parallelizable Spark variable, and then you could read the JSON from there. So one way or another, we're trying to get the data into Spark, like using the Spark libraries. This one's like the simplest one for me to use. I'll go back to the notebook. So it should be just as easy as turning this into a list. That didn't really help, did it? Okay, one more time and we'll move on. Illustrating the purpose of this. We'll try to do a SQL connection to JSON loads, JSON string. Oh, because instead of dumps, it's loads. I forget I always have to look up the difference between the two. So let's try this one instead. Okay, Okay. JSON loads. And did not do it. Let's run it from the top one more time. JSON loads, Spark, create data frame, data dictionary. Okay. I think this maybe creates an object that has a schema in it also. Is it like a JSON object? Or instead of just a text file, it seems to need a schema to be able to do that. And this still doesn't work. Also take a look at that too. Get a working piece of code there for everyone. I don't want to spend too much more time on it because I want to be able to get to other things. But let's also try to do a T-SQL workbook here. Or Spark SQL. File in OneLake. Query a Parquet file. Let's make that specific. Okay. Seems overly complicated. It's already overly complicated it. Claude has a talent for that sometimes too. So April, to your point, sometimes Claude needs some good guidance on giving you decent code. To be fair, we were debating on how effective Claude was, and I think it is a lot, but sometimes you really have to be able to guide it. Let's try to use Spark SQL. And it always wants to generate code. That's how you can tell that it's specifically meant for developers. Because when you ask it a question, it always tries to write code for you, no matter what, almost no matter what. Okay. Let's do another notebook. Let's go back to workspace. Here, let's just tell it, provide an example of Spark SQL query. Spark SQL basic query. So you use SQL to execute it, Spark library, SQL, and then you show results. Let's go ahead and do this. Hoping that it works. So I'll go to new workbook. Notebook. Probably not going to work like that. Okay. Okay, you have your query, SQL and show. Okay. Let's try to just query one of our tables instead of a file in the data lake. Let's query, or in the lake house, let's query one of these tables that we've created. So we'll go over here, add lake house, existing lake house. Guess without schema. Say lake house, first and last name, ODSA. Oh, there we go. So we connect our lake house there. Say select from dim coins. We'll just select star and limit the first 10 and then execute Spark SQL. Let's see what happens. Be amazing if one of these worked. You don't have to import all the Spark libraries because some of the Spark libraries are implicit. They're already loaded for you. Bam. I'm so happy that one of my examples worked. And you can load this into a data frame. You can also do, say we printed the result. So let's take this result and load it into a data frame. It is sometimes still tricky. So this result is actually a data frame, and then Spark data frame. This returns a Spark data frame. The Spark .SQL query executes the query, returns a data frame, and then you could use the .show function to show data frame. Okay. So wrong notebook. So you hit Shift and Enter for a new window in the notebook, or a new section in the notebook. Okay. So we're saving it. Result. I think result type allows you to just to show what type of object it is. Ooh, query is not defined. Here. Just make sure I get that right. Oh, you just do the type. I saw it. Oh yeah, I got it right, I think. Let's run this from the top. Okay, so it's running the query from the table in the lake house. Okay. Query is not defined because it's called basic query. That is why. And I spelled print wrong. So it did the same thing really, except it did results.show. Data frame object has no attribute type. Okay, anyway, you can take my word for it being a data frame. So that's two ways you can use it. You can use, there's Spark SQL. Well, have Spark Python and used the SQL function in there. It's also Spark SQL. Oops. That you can use to query the tables in a SQL-like manner. You can use R to create your models, or you can also do big data type transformations with Scala, use Python, T-SQL Analytics. Okay. Let's keep moving. Okay. So quite a bit you can do with Spark, and then you could also include those within your data factory pipelines. Okay. So why use APIs for data science workflows? So the rest of this is going to be integrating that live CoinWatch API into taking it from the live API CoinWatch or live API CoinWatch API into your on-demand SQL pool. That will be the class exercise today. But the purpose is to saying why should we do it. Go back down. It enhances data APIs, especially those REST APIs for data sciences like GET or POST type request for information. They enhance data accessibility, quality, and automate data integration processes for model deployment. So data quality in particular, it's like you're always, you know what data that you're accessing. You have an endpoint, it's always consistent, it always produces the same result. That's like the stateless REST API. It's accessible as long as you have an internet connection and that other endpoint is available. And then automating data integration is probably the biggest one. So we'll see here where you can use a Synapse data pipeline to be able to automate data integration into directly into a database. You can connect to it directly and have that repeatable process. So you could also do all of this in Python like we just did. You can create your Python notebook, handle the JSON response the way you want, or you can do it visually through, you can also do it visually through Data Factory. Or you could do a combination of both, write your Python code, integrate that into Data Factory, and use it there. I'd also call that automation. I tend to go with the lowest amount of code that you have to write or maintain. So I would go the visual route. But sometimes requests can be more complicated than that too, and Python helps to be able to handle it a little bit better. So here's why it's crucial: provides direct access, governed access to data sources such as databases, web services, and systems. Talked about that in the second lecture. It's always the same. Somebody creates the rules. It's stateless, and you're always getting the same data. You know what the source is and how you're getting it. For real-time analytics, so and things outside of REST APIs like webhooks, or I can't think of it off of the top of my head, but for streaming videos, you can use other different types of APIs to be able to get real-time data. So difficult within relational database systems, especially if like millions of people are trying to get them. This data is real-time data is often better through some REST API for programmatic access through REST API and be made more efficient. And then model deployment and management. So this is the other side of it. In our last class, what we'll do is build a Python model in the data and Synapse data science. Once we do that, we will deploy it as a web service, as a REST API web service, so that it can easily be accessed by other systems or other programs that you create and so forth. So that's really useful because if you think about like Google Cloud Platform, instead of having a bunch of proprietary models, they offer a bunch of models that they've created by REST API. Usually it's in the form of image recognition. You would send it an image and then it would return like what the image is. And that's overly simplified, but that's the idea of having that available instead of having to like write a bunch of code for the integration or to be able to do it yourself. and then having it just available there in a REST API makes it a lot easier. So deploying models that way is also very effective. Okay. So benefits of automating the data collection using APIs and data pipelines is a data retrieval, very easy, and it's automated, streamlining it. Automated data processing, automates the manual collection and transformation of data. So oftentimes maybe before you had to write a query and then export the results and get it in the right format to be able to upload to a database. Now you're able to connect directly to that API and then just send it by pipeline, transform it by pipeline the way it needs to be. Enhances data quality, we talked about that. Scalability and flexibility. So APIs and data pipelines enable scalable and adaptable data collection, accommodating evolving needs. So scalability, as far as if lots of people are using the REST APIs, the owner of them could scale up the processing. And that's oftentimes why they have rate limits on APIs. So they don't want you hitting or having like 1,000 requests a second to a REST API unless you're paying for it. So April, she just actually ran into that herself using Live CoinWatch API, is that she sent it a bunch of requests in a short time, although harmless. They don't really want you using up all their processing power unless you pay them some money for it. And that's where you get the rate limits. Okay. So recapping, so we went through a full introduction here of Azure Synapse Analytics and how it is in Fabric, and then how similar it is to what is also provided in Azure Synapse Analytics. So it's an integrated data science and data engineering platform, and it has a number of components that you've already seen, all integrated in the same platform. It's a data engineering IDE, so not the same layout as Synapse Studio and Azure, but it has all those components that we covered. You have SQL pools, serverless and dedicated. The serverless one is for analytic purposes, and Apache Spark Pools is the same. It's also serverless. And then automating data is like the most important thing about using APIs. The accessibility and everything is too, but being able to automate these into integrated pipelines, especially for machine learning purposes where you have a constant need for new data and to update the score and update the current models and make predictions, having that constant data flow is really important. So those are important benefits, and then you could use Synapse pipelines to do that. Okay. So we're going to go into a demo of how this works. So I tested this before, and it worked earlier for me, this part of it. So don't mind those last two directions. So what we're going to do here is create a pipeline in your Fabric workspace in the data engineering module. And then we're going to use the copy utility to be able to connect to the REST endpoint. And their REST endpoint will be the source data using some of these parameters. And then you'll set the target to actually your on-demand SQL data warehouse. So let's go ahead and cover this so we can get together the class project and work on some of our questions we have with the homework. Okay. Everything crashed behind the scenes. Everybody, connection's been pretty good tonight?
Mm-hmm.
Loud and clear?
Yeah.
Sweet. Yeah, I brought my wireless hub, and instead of connecting to it wireless. I have the Ethernet connection. Seems to be working pretty well.
Nice.
Okay, so let me find my example here. Can everybody see my web browser right now?
Yes.
The entire screen. Okay, good. So I actually created this in my workspace. So instead of clicking through all these tabs, I could probably do that. Like I said, you could connect to this CoinWatch API. You could write Python code that saves this into the data lake, and then you could use that JSON file and load it into table. There are a number of ways you can do these processes. For this example, I'm just going to do purely the visual one without having to write any of this code. And you could also put this in the middle of a process so that you could trigger this process, it gets the new information, picks up that JSON file and puts it into your data warehouse. You could do that. You can do it any number of ways. We'll do the purely visual one this time. So I created a pipeline for this, and I named it Pipeline REST API DW Crypto Overall History ODSA. So I'm saying it's a pipeline. It's a REST API to the data warehouse with the crypto overall history, and then I just put ODSA on the end of it. So if you click new item, you do a data pipeline. I've already created one, but just walk you through the step of creating a new pipeline. Oops, sometimes it takes a second to load. If I just created pipeline one, you'll have the new interface here. I'd give it a similar name to what we talked about. I like to make the pipelines descriptive, so it's very easy to see visually like what it is. You have your naming convention, and it starts with pipeline. It's like a to and from, like where it's from, where it goes to, and then maybe your initials on it. Okay, anyway, when you create one with that name, it takes you to Explorer. I'll just go ahead and click on this one. So you can do all of this through the copy data utility. And one thing I forgot to mention before we run this is that you're going to want to set up your on-demand warehouse, because within Data Factory, you have a source data set that you define, and this source data set, we'll cover it in a moment, but it's an API connection to the crypto coin overview API, the endpoint. And then you have a destination. So I've already created this warehouse demo user ODSA. So let's go ahead and take a half step back and create that first. We need to create our source. So inside of your data engineering workspace, you can create new data warehouse. And this is the on-demand data warehouse. I've already done that. It's very similar to the pipeline. It'll just ask for the name and then create that new item. I have already done that myself with this name. So I'll click on that. I'll give you a second to Go ahead and create that if you're following along. And then once you do, you can go in here and then you should see a database with that name that you created. And then if you expand schemas, you'll also see like your traditional schemas. So it's set up a completely new SQL Server database, on-demand SQL Server database for you. Then you could expand tables and everything. So we have it set up. We have a brand new SQL Server on-demand data warehouse that we're ready to pipe data into. And you can even do that. You can start to build a warehouse through data flows, pipelines. It tries to help you out here as much as it can. Okay. So within the pipeline, I went back to the pipeline. That pipeline, REST API, data warehouse, crypto overall history. You'll see some options. You could probably give it a better description than copy data one. You can do copy crypto data API to data warehouse. Something descriptive. You could call it ODSA if you want within the pipeline. You have a bunch of options. Usually I just go to default. Some of them will be like how many times do you retry the REST API if it's unavailable. So your source, what you want to do is set up a source connection. Here you would go to, if it's in a brand new one, it should give you an option for more. Okay. So inside of here, choose the data source to get started. There's one called web. There should be. View more. Let's go ahead and view some more here. Oh, there's one called REST. That's the one I'm looking for, that one. In the base URL, you want to give that your endpoint name. So you have the live coin watch API. If you went back to this documentation, we're just going to do the overall. Also, if you set it up, so we'll just go down to it here. Coins, overview. Then you could do overview or overview history. Either one, but we'll just do overview to make it simple. And then it's how crypto is doing at the moment. Set that as a base URL. It's okay to set this authentication as anonymous because we'll send it a header with our API key here in a minute. Okay. So we've created that as a connection and a data source. So if you've done some work ahead of time within Postman, you could use some of that. Let's do web.postman.com. I'm showing you how this all connects together now. So I created a new collection, Live Coin Watch API. So I did an overview. We'll just do overview. And I define the body of what I'm sending. Here is the currency USD. And then the header, the only required header that we need is this X API key. And then that's the API key you get for registering with Live Coin Watch. And then you may see it in this Live Coin Watch tools after you do it. You can copy and paste it in here or even play around in their API playground. So using that API key that you get, you can even test it here in Live Coin Watch. So that is the response that you should receive. So now we can take this information and automate it by putting it in a pipeline. So instead of running it over and over again manually, we can put it in a pipeline and automate it. You could write Python code to do it too, which would be kind of like writing it, but we're going to do this visually. So looking at API documentation, the request method is post, because we want to send it a request body to tell us to return the information in USD, currency in USD. We give it some additional options, and then we define the header. So the only header we need is that X API key with that value. And we know that from both the .api documentation and Postman. Okay. So we have all that set up in Data Factory. If you just want to be able to see if it works, you set it up right, you can test connection. And may take a second, but should be okay. And then at the same time, I could even preview data. Preview data, it should just send back that response, JSON response. Taking just a minute. Yep, there's the data. It's just that one single observation with the total market cap, volume, liquidity, Bitcoin dominance. Okay. So pretty straightforward. Don't have to put that in the JSON parser or anything. It's just a single record with those columns and values in that dictionary. So if I click on this, we want to sync this now to the data warehouse that we created. So if you go to connection, hit more. We don't want a new destination though. Oh, you scroll down and then you could use the warehouse ODSA first and last name, or warehouse ODSA first name and last name ODSA, the one that we just created back here in our schema. So I've already done that myself. That's where you'll select that connection. So one thing we can do is the table options are important. You could use an existing table. So if you already have a table that has defined names and columns, And you have that defined schema with the data types for the columns all set, hidden probably primary keys and everything. You can use that existing table, or you can just have this one automatically create a table. I'm going to have it automatically create a table. And the table is going to be in the crypto.olap schema. And here's the name of the table. Table. I always start my tables with table and then underscores between each one of the names. Now, go back to SQL class. There's not really any set standard for naming tables or anything like that in SQL or even code so much. You just really want it to be readable for yourself or other people. If you go to bigger companies, they may have some set standards on how to name things. I've had that before, how like database administrators want things named. You all work together on it, but this is how we set it for this one. So it's going to create a new table in that schema. If you're just doing updates, if you're just getting the most recent information, you probably just want to use existing. And then what you can do in your connection, say you were just getting new dates, you could go and there is a way to be able to set this to a variable, and then you could make those dynamic variables. So if you had a start date and end date, you could dynamically calculate those. Ignition. I don't see that here in this option or here though, but I know it's around here somewhere. But anyway, destination is your data warehouse table. You're going to create a new table. And if you hit import schemas, what's really cool about this is that it will detect that JSON schema, the structure of it, and it'll put it into a corresponding table in your database or the corresponding column in your database. It'll map that to a column. So it's cool is that now it has cap volume, liquidity, and BTC dominance like we saw in that JSON file. It detects the types automatically. It did a pretty good job there. And then it maps it to SQL table and those types in SQL table. I've even seen it done on pretty complex JSON files that are like nested, deeply nested JSON files. What it does is it does an operation that's called flatten, and then it does the best job possible of flattening it. Now, if there are only certain things you want to get out of a JSON file, maybe that's where you would write code for it, where you really wanted to handle the JSON file in a certain way. But this does a really good job of mapping even relatively complicated JSON files. Also, there's an activity in here that you could do. And maybe this is, you see that you could do notebooks and scripts and certain things. I think these are a little more, let's see. I think these are a little more limited here to in Azure Synapse, like limited to just the types of things you need for analytical purposes. But I know that there's an activity in here that helps you parse JSON files. So you could load a JSON file and you could do more options to be able to like specify the structure and even do a better job of it. Let me, let's cancel that. believe that you can do some of that through data flow also. I'll take a look at doing some of that. But just as simple, straightforward this, it's mapped all of it. Settings, I usually do all of this, the default. There's some parallelism, so breaking it down into multiple pieces, and then optimization you can do. But let's go ahead and run this activity. So you can go over to run, and then you could validate just to make sure you haven't missed any settings. You could schedule it. You can add triggers and schedule it. So you can run this at certain intervals or when certain events happen. You can actually build this to be pretty complex, like multiple steps deep. Oops. Yeah, you could set different alerts to be able to alert you if it doesn't execute, or you can schedule it to set certain times for it to be able to run. So now that we validated it, we're going to run it. Okay, so when you run it, it gives you this output, and it tells you the progress of the pipeline. So either it says in progress if it's running, it'll give you an error if something happened with a message, or it'll say ran successfully. Then you have these input options. This is like the JSON file for the options that you selected for the input. And same for the output. Here in a second, once it produces it. Oh, task succeeded. You have that output. This is actually the output of the pipeline itself. Like information about it running successfully. Can view run details if you'd like. We manually triggered it. It says what time. You can look up a history of this also, view run history. But let's go ahead and see if this made it to our data warehouse successfully. So when you're in here, you need to refresh. It should create a new schema here with table. It doesn't look like it did. Try to refresh this one more time. Sometimes I just reload the whole screen. Let this reload. And I still don't see that it created the new schema. So let's run this one more time. Let's see if it gave us any information about creating that schema. Maybe it didn't. Data written. So advanced information. Doesn't really say that much about the table I wrote it to. So let's go.
Did you already have that warehouse page open by chance? Because I have the same thing where I had it open, but I didn't hit the refresh button in the top left. So it didn't look like it created anything at first. So you
But it did.
It did for me, yeah. Up
I
in the
don't
top,
see-
top. Yeah, I guess it's refreshing there too. Maybe does it? I just did that very top one. Mine popped up eventually.
Skylar, did it create that new schema and everything? The crypto
It
OLAP
did,
schema?
yeah. Yeah.
Did I point it to the wrong place? It I swear it worked for me earlier. Destination. Warehouse demo user ODSA. Oh, because I
Okay.
pointed it to the wrong warehouse. That's the thing. I wasn't doing it consistently like earlier. And like before I logged in today, I'm like, where did all my work go? Then I realized I did it under like my demo account. All right. So I am in the wrong warehouse. Warehouse ODSA, it wasn't that one. Which one was it? Warehouse demo user ODSA. Which may not even be in the schema. Warehouse demo user must be in a different workspace. Warehouse demo, yep, it went into like my default workspace. Okay. That's it. I think must not have set the schema here at the beginning. Just looking at this. I don't want to spend too much time on it. Let's just go with it because I'm gonna get to homework. Yep, so it created the crypto OLAP schema table overall fact that you can now query out of your data warehouse. So that's why I did one. I have 2 records because I did one earlier today. All right, that is how you would connect API REST connection. You can do it through the copy utility in Data Factory. Or you could potentially write a notebook or a script. There are a few different ways you can do it, but we took the visual route for the exercise. However you do it for the class project is totally up to you. Like I said, there are a number of ways that you can do these things. You could even, I believe, do it through data flow. You could use the web connector in a data flow and then get the data in Power BI and then take it down here and load it into a table. However you want to do it is fine. Ultimately, it's showing you this way, this visual way of being able to do it with Data Factory. All right. So that ends that demo. I'm not going to stop the video because I just want to go through the homework and class project really quick. And then we'll stop the video. Okay. So homework two is all about cloud storage and processing data in the cloud. So these are the last 2 lectures before this one. So what you'll end up doing is using data flow, data factory, and those CSV files that you put in one lake, and then copying that to data warehouse table like we did tonight. So you have those 3 files. You can also use the crypto data Excel file because it has the same data. You'll see that on each one of these tabs. It has historical information. So the intent is to use Fabric data warehouse to create this data model. So you have 2 fact tables and a dimensional table for the analytical data model. Once you do that, once you load that data into the data model, you create a view with summarized daily crypto data, or some type of summary or some type of view to be able to view this data. It can be daily or however you'd like to do it. So the steps are as follows. You'll create that OneLake connection to Data Factory like we did. Except you'll use it with the CSV or Excel files, create the data warehouse, connect Data Factory to the data warehouse. So either the CSV or Excel files out of OneLake, then create create that pipeline that maps the data to the data tables. You could create new tables for the first time around. For this exercise, create them as new tables since it's a first time load. And to make sure it's correct, go ahead and visualize these in Power BI and make sure you get the same results that are in the Excel file. So what I mean by this is oftentimes to make sure data loads correctly, you do record counts, make sure the number of records are the same between what's in your database table in Power BI to what's in the CSV files or Excel files. And then just spot check, are the dates correct? Are the fields correct? Does it summarize to what you'd expect and so forth? So submission for the homework will be screenshot of the pipelines, database schema that you create in the warehouse, create that view, and then the Power BI visual with summary and counts. So taking it to the next step, creating that pipeline in the final project, in the class project, we'll do what we did tonight, is start to get new data out of the REST API and then refresh those tables using that data, and then we'll build a predictive model and deploy it on top of it. Pretty exciting, a lot, but it's coming together, and I'll show you the class project real quick. That leads into the class project. And I'll share this in Slack. But so this is a data engineering project for predicting crypto, CRY, crypto's future market cap. So what is the market cap going to be at some point in time? I'll let you decide on what that prediction is. So the purpose is to engineer an end-to-end product, just overall high-level purpose of this project outside of crypto data. It's to engineer an end-to-end product such as like a machine learning model that would be used in a business environment by knowledge gained in this course. This is like the practical application of everything that you've learned. I have this process that I usually do for data science processes. Just understanding the business problem. For this one, it's pretty straightforward. We're just trying to predict these prices. Understanding the data, so understanding that out of live coin watch, the different endpoints. Preparing the data is all the steps underneath that we're doing. Loading it into the data lake, using data flow, loading it into data warehouse to use for analysis. And then building the model, data flow, and pipelines. So building the data flow and pipelines and Synapse Analytics around that. Testing and evaluating your model, making sure it does a decent job, although not as important in this class because we're just engineering it. And then deploying it by REST API, monitoring it in Power BI, and then updates and maintenance in the pipeline. So project steps, this will look familiar because this is one of the workflows that you can select within your data engineering. I believe I'll show you real quick. If you get lost at any point and not sure what the next step is, I started to point out in data engineering some of those things that could help you out, like the predefined templates, like basic data analysis. So get data, store data, visualize, and track data. I just put a model step in between it. And then it says workloads, and then some of the things that you need. If you ever get lost or want to even start there, you could potentially start there too. And when you do, I'll just call this help. Just want to show this as an example. It'll actually give you breadcrumbs to different items to create. So you could do a data flow or data pipeline, storing data in the warehouse, create a report, scorecard or dashboard. We'll just recreate a report for this one, and then track data. So we cover track data last in the real-time intelligence, and you don't have to worry about it. But if you feel interested in digging more and implementing as part of the project, be kind of a cool thing to do. Okay. So the rest of the project, I list out the project steps. So from the very beginning, from creating a Fabric workspace, creating one lake and placing the CSV files there, data factory pipeline, creating a pipeline in Synapse Analytics. So this one is creating it in Data Factory. This one's creating it in Synapse Analytics like we did tonight to get the data from the Livecoin Watch REST API. On Monday, we'll cover how to create these predictive models using the data science, so the Fabric data science module. And then you'll use that data that you created in that view in the homework. Then we'll deploy the predictive model via REST API, visualize and monitor results, refresh the Synapse pipeline to ensure automation. That's how it all comes together. So that was a lot. Does anybody have questions about the project? So completing homework 1 and 2 is going to help out a lot with these items. You'll have a lot of it done, actually, by having these CSV files in OneLake tables and creating in homework 2, creating the pipelines. And then we just have to cover at this point, we just have to cover how to create the predictive models. And then don't worry, Melinda, because I'll create a predictive model for you to deploy. Looking forward to it. That's a lot. Does anybody have questions about the class project? I'll give the class extra time. It won't be due by next Wednesday. I'll give you till the fall. I believe I set the following Monday because Wednesday is Christmas. So that'd be like the 23rd Monday, so that I can get feedback to you before Christmas. I'll assign the final exam on the 20th. Yep, 23rd. That's when I set it. And we'll have a working session next Wednesday. Cover the homeworks and projects. Questions about the class project? Seem confusing or straightforward? Seem like a lot, not enough. I packed more in there.
No questions yet. I'm sure once you get into it.
That is the vision from in this class, working from end to end, from very much having the original data and setting up the data lake all the way to deploying machine learning model, and this all the steps in between. Now, how you do it, it doesn't matter to me. Like if you want to create your predictive model using Spark, if you wanted to take that route, that would be okay with me. What I'd like to see is those notebooks in some type of pipeline. It says Synapse Analytics pipeline. Just to show that you're using those type of things for triggering and automation. So this is ultimately like the test in front of you. There are a few different ways you can solve it. You have the problem at hand, and now it's just a matter of going out and solving it with the skills that you have inside of Microsoft Fabric, the platform you're given. Okay, if there are no questions, actually ended up with the demos today taking a little bit longer, but I think it was good to spend more time on demos today. I open the floor entirely to any questions about homework now or project or anything in this class.
For
Now,
homework one,
yeah,
sorry.
Skylar.
I was gonna say for homework one, how do you want that submitted?
I forgot to mention to everyone, just directly in your direct messages in
Perfect.
Slack is just fine. April put it together all in a zip file, that's fine. Or if you just toss me snapshots or organize it so I can tell like what snapshot or file goes to what question.
I threw it all in the Word doc, including the files. So we'll see how that works. You know how they're like the embedded file in there? So if those don't work, let me know. Like if
Okay.
it doesn't
I don't
let
know.
you access it or something.
I don't know if it works embedding files in Word or not. You'd think I'd know having used it for 30 years, but we'll see. Maybe it does. I think it creates like a link.
Yeah, I think, yeah. And if that doesn't work, just let me know, and I can always send the raw stuff. It's not a take me 2 extra seconds.
Try to look through submissions and get feedback as soon as I can because it relates directly to the final project. I'll also go ahead and end the stream for now because we'll just answer questions about homework. So everybody, for tonight's class on API integrations for data science, the next class that we have is creating machine learning models and deployment and creation of machine learning models. Thanks, everyone. Not cutting you off.